Inshallah, in this class, we are going to start Fourier series. We are going to do one or two questions based on the interval 0 to 2 pi. 0 to 2 pi. What is Fourier series? Nothing but the expansion of f of x in this form. So you must by heart this formula first. What is f of x? A naught by 2 plus sigma n equals to 1 to infinity an cos nx plus bn sin x. Now here we have to find three values and substitute. We have to find a naught, then an, then bn. So what will be a naught? A naught formula, this one, 1 by pi 0 to 2 pi. In the interval 0 to 2 pi, we are taking 0 to 2 pi f of x dx. And an will be 1 by pi 0 to 2 pi f of x cos nx. And bn is 1 by 2 pi, sorry, 1 by pi 0 to 2 pi f of x sin x. What is here common? 1 by pi in all these three, and 0 to 2 pi is same for all these three. What we have to by heart? For a naught, we are having only f of x. For an, f of x into cos nx. For bn, f of x into sin x. Okay. Some basics also we are going to use here. We must know this all things. First thing is, you see here, sine 0 or sine pi or sine 1, n to n pi, whatever we get, or sine n pi. This all values will be 0. This all values will be 0. Whenever we get one of this value, it will be substituted to 0. Sine 0 or pi or 2n pi, whatever, its value will be 0. Because here cos 0 is 1, cos pi is minus 1, cos 2 n pi is 1, cos 2 n pi is 1, whereas cos n pi we can write minus 1 for n, because it will be 1 plus there 1 minus 1 plus 1 minus 4 alter. Therefore we write minus 1 power n. Now whenever we multiply two functions in here in integrations, we are going to use this formula. Integration of u equals to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4. Dashes means differentiations, and v1, v2, v3 means integrals of v. Now we know what is the formula of integration of sin x is minus cos ax. But what are the coefficient of x? We have to divide by this. A is the coefficient of x, so we have to divide by. In the same way, integration of cos is sin ax, but the coefficient of x is a, so we have to divide by a. Integration of x power n is x power n plus 1 by n plus 1. Integration of x is x squared by 2. Integration of x cube is x cubed by 3. Suppose we are having like this integration of ax plus b power n. So how we can write ax plus b power, integration of x power n is x power n plus 1 by n plus 1. But we have to divide with the coefficient of x, so we must get a here. In the same way, if we are differentiating of ax plus b whole power n, d by dx of x power n is n into x power n minus 1. Now we have to differentiate this also. This constant b is 0. D by dx of x is 1. 1 into a is a. So we'll get a here in the numerator, whereas in integration we get that constant in the denominator. So let me try one question based on this formula. Now see here, there is a question on the board. F of x equals to pi minus x by 2 whole square in the interval. Then show out f of x equals to pi square by 12 plus sigma n equals to 1 to infinity cos nx by n square. And from this, hence we have to deduce this 1 by 1 square minus 1 by 2 square plus 1 by 2 square, so on. So what is given here? F of x equals to this 2 square is 4. I'm just writing this for outside. Okay. Now this is the Fourier series. Now a naught by 2. Just now we have seen sigma n equals to 1 to infinity a n cos nx, and similarly that b. So let me start with a n naught first. So what is a naught here? A naught equals to 1 by pi integration of 0 to 2 pi. What is here? 1 by 4 into pi minus x whole square dx. Now you take out this 1 by 4 outside, we can write like this 1 by 4 pi. Now let's integrate this one. What is integration of x power n? X power n plus 1 by n plus 1. So 2 plus 1 will be 3. So this will be pi minus x whole cube by 3. But we know we are having minus 1 with the is the coefficient of x. Minus 1 is the coefficient of x. So we have to divide by minus 1. So after differentiating, after integrating, we have to write the limits here. We have to write the limits here. Once more, watch carefully. Integration of x power n is x power n plus 1 by n plus 1. 2 plus 1 is 3 by 3. but we have to divide with the coefficient of x is minus 1, so dividing by minus 1. So we take out this minus 12 outside, this will become minus 1 by plus into minus minus 4 is a 12 pi 12, sorry. So we have taken this outside. Now let we apply the formula upper limit minus lower limit. Upper limit means in x, in place of x we must write 2 pi. So this will become pi minus 2 pi whole cube minus lower limit means 0. So this will become pi cube. This will become pi cube. Once more you see, we will continue here. See here, next one. So this pi minus 2 pi will be minus pi cube. So minus 1 by 12 minus pi cube will be minus pi cube whole cube. No, so take out minus pi cube. This is also minus pi cube. This will be minus 2 pi cube minus 2 minus plus 2 pi cube by 12. So this will, we get cancel this one 1 0 and this will become 6 0. So this will be pi cube by 6, pi cube by 6. So let me sorry, I forget to write this pi here. No, we are having pi now here. So this will be 12 pi. So what we can write now? Minus into minus plus 2 pi cube divided by 12 pi. So 2 1s are 2 6s are, you get cancel here pi square. So what is left here? Pi square by 6. Okay. So just now we got the value of a naught. Okay. And I am writing here. We got the value of a naught as pi square by 6. Pi squared by 6. So what is the next step? Next step we have to find an. We have to find an. So let me first write the formula of an. What is the formula of an? Here we are having an. This formula is 1 by pi integration 0 to 2 pi f of x into cos nx dx equals to 1 by pi integration 0 to 2 pi. What is f of x here? This is the f of x. 1 by 4 constant, we can write this 1 by 4 outside. So we can write this 1 by 4 pi f of x. So 1 by 4, we take, what is left here? Pi minus x whole square into cos nx dx. Okay. Now see here, to expand this one, we have to suppose this as integration of uv. So u here will be pi minus x whole square and v is cos nx. So let me differentiate this. Always you have to differentiate u until we get 0 constant. So u dash. Now d by dx of x square is 2x. So this will become 2 into pi minus x. But in internal also we have to differentiate. Pi is constant 0, x is 1, 1 into minus 1 minus 1. So we get minus 2. Again you differentiate u double dash minus 2 into. Now d by dx of pi is constant, x is minus 1. So this will minus 1, thus it nothing but u double dash equals to 2. Now we cannot go for u triple dash because it is constant. Now we'll get 0. So we have to integrate this also. Now we have to integrate this v1 equals to integration of cos is sine. So sine nx. But the coefficient of x is n. So we have to divide by n. In the same way v2. Integration of cos is minus sine. Sorry, sine is minus cos nx by n. Again n, we are getting 2n. So n into n will be n square. And the next thing is, we must go one more. v3 equals to minus. Now what will be the integration of cos is sine. So this will become sine nx by n. Again we are already having n square. Again 1n, that is n cube. So we have to use like this formula. Integration of uv equals to u v1 minus u dash v2 plus u double dash v3. Because we are getting u double dash v3. So we have went up to v3. Now u triple dash will become 0. So let me substitute this here. We are having 1 by 4 pi. 1 by 4 pi into. Now we have to use this one formula. What is the formula? U v1. U is, we are having u as pi minus x square u into v1. v1. What is v1 here? Sine nx by n minus, I'm writing here minus u dash. What is u dash here? U dash is again minus, we are getting minus again. So minus of minus will become 2 into pi minus x u dash v2. v2 again we are getting minus, so plus into minus again it will become minus cos nx divided by n square. So this is the first term, second term, then third term plus u double dash. U double dash is 2 into v3 is minus, so plus into minus will be minus sine nx by n cube. So what will the limits here? We have to write the limits here. 0 to 2 pi. 0 to 2 pi. Again you see here u v1. U is this, v1 is this, minus u dash. U dash is this, okay, minus of 2. U dash is, sorry, u dash is minus of 2 into pi minus x into v2. Again minus minus, it will become minus. 3 minus you are getting, so you get minus. In the same way u double dash is 2 into v3 minus. Okay, now what is the formula we are having? Upper limit minus lower limit. Upper limit means we have to keep in place of x 2 pi. If we kept here 2 pi, it will be sine 2 n pi. I just in the starting I showed, now this will be 0. This is 0 minus, if we keep here in place of x 2 pi, it will become 2 n pi. Cos 2 n pi is 1. Just now in the starting we have seen 1 into minus 2 will be minus 2 into, in place of x we are adding 2 pi. So this will be pi minus 2 pi into 1 by n square. Okay, minus the last c here. When we keep here 2 pi, this will become sine 2 n pi, that will be 0. So this is upper limit minus, no lower limit. Lower limit means in place of 0, if we keep x 0, sine 0 will become 0, sine 0 will become 0. Now what will be here? Minus 2, in place of x, if we keep 0, it will be minus 2 pi. Cos 0 is 1 by n square. Now let me solve a little more. So here, watch carefully. What will happen? 1 by 4 pi into pi minus 2 pi is minus pi. So minus into minus plus 2 pi by n square. 2 pi by n square minus minus plus 2 pi by n square. So this will become 1 by 4 pi into 2 pi plus 2 pi will be 4 pi. 4 pi by n square. So pi, 4 will get cancelled. What is left here? 1 by n square. So we got the value of an. An is 1 by n square. Let me write this here. An equals to 1 by n square. Okay, 1 by n square. Now let me go for bn. What is the formula of bn? Just in place of cos we have to write sine. Just in place of cos we have to write sine. So let me continue here. See here. Now bn equals to 1 by pi into f of x sine nx, okay, dx. So 1 by pi integration 0 to 2 pi. What is f of x is this? We take out 4 outside. Again, what is left here? Pi minus x whole square into sine nx dx. Now again, you see here we have to fill this as u and v. Just now we have done. So what is u here? U is pi minus x whole square. Differentiate this u dash d by dx of x square is 2x, 2 into pi minus x. If you differentiate internally, pi is 0, x is minus 1. So minus. Once more you differentiate, minus 2 into d by dx of pi is constant 0. Minus d by dx of x is 1, minus 1. So minus 1 is that will become plus 2. Now in the same way, let me go for v. V equals to sine nx. Now v1, integration of sine is minus cos nx. But the coefficient of x is n, so we have to divide by n. Again v2 minus integration of cos is sine nx by n. Again n is n square. One more v3 minus integration of sine is minus cos. So it will become minus 1 plus cos nx by n cube. Okay. Now what is the formula we are having? Integration of uv equals to u v1 minus u dash v2 plus u double dash v3. After u double dash we get 0, therefore we stop here formula. Okay. Now let me substitute here. Outside we are having 1 by 4 pi. 1 by 4 pi. No, this formula is u v1. U is pi minus x whole square. U into v1 is this one. So minus I am writing here cos nx by n minus u dash. U dash is this one. Again minus 1 is plus 2 into pi minus x into v2. V2 is this, again minus, we are getting minus here. that will be sine nx by n square. The third term is plus u double dash. So what is u double dash? We are having 2 into v3. v3 is cos nx by n cube. So what are the limits here? We have to write from 0 to 2 pi. So what we have to use here? Upper limit minus lower limit. Upper limit minus lower limit. So let me start here. 1 by 4 pi. First substitute upper limit. If we substitute upper limit 2 pi, this will become 0 sign. Now if you see here just now minus of pi minus 2 pi will be minus pi whole square. If you substitute in place of 2 pi here, it will become cos 2 n pi. Cos 2 n pi is 1 by n. This will become 0. This will become 0. Now here, if we cos 2 n pi is 1 plus 1 into 2 is 2 divided by n cube. Divided by n cube. So this is the upper limit minus. Now lower limit. Lower limit means in place of x we have to write 0. So pi minus 0 will be pi. This is minus, no, minus pi square cos 0 is 1 by n. Okay. So this is one term. Then this will become 0 plus. What is here? Cos 2 n pi is 0. Cos 0 is 1. This will become 2 by n cube. 2 by n cube. So let me continue here. Now watch here, let me solve it more. I think this will become 0. You see here, 1 by 4 pi into minus square will be plus, this will become minus pi square by n. Minus pi square by n. So this is plus 2 by n cube. Minus into minus plus pi square by n. Minus into plus minus 2 by n cube. Yes, here I think this will get cancelled. Minus plus minus plus. So 0 into a number 0. So now we got the value of bn also. So what is the value of bn? So bn equals to 0. Bn equals to 0. Now let me substitute in the Fourier series. Okay. So we got the values of an, bn, and a0. Now let me substitute this in the function. So what is the formula? Watch carefully here. We are having f of x. So f of x is 1 by 4 into pi minus x whole square equals to a0. A0 is pi square by 6. Again we are having 2 here, so it will be 2 plus sigma n equals to 1 to infinity an. The value of an is 1 divided by n square into cos nx. I can write like this, cos nx by n square. Since the value of bn is 0, so 0 into a number is 0, this will become 0. This will become 0. So this is the proof. Just we can write 6 2s are 12. 6 2s are 12. So this is the value of f of x. F of x in terms of Fourier series. This is f of x in terms of Fourier series. So we have proved this one. You see here, f of x equals to pi square by 12 plus sigma n equals to 1 to infinity. We have proved this one. Now using this, we have to prove this one. Again using this, hence deduce means using this. Very easy, watch carefully. Okay, let me expand this one. First let me expand this one. How to expand? Watch carefully. Write this as it is, 1 by 4 into pi minus x whole square equals to pi square by 12 plus. Now you keep in place of n 1. So we get cos 1x means cos x by 1 square. In place of n, if you keep 2, this will become cos 2x by 2 square plus cos 3x by 3 square plus cos 4x by 4 square. So this will become the series, Fourier series. Okay. Now watch carefully. From this, what we have to prove? We have to prove, watch carefully. 1 by, we have to prove like this. You see, 1 by 1 square and minus 1 by 2 square plus. We have to get alternate, plus then minus, then plus then minus. Okay. We have to get the alternate. How? Let me do one thing. You keep in place of x as pi. Put x equals to pi. Why? Because cos pi is minus 1. Then if we keep here x, it will be 2 pi. Cos 2 pi will be plus 1. Cos 3 pi will be minus 1. Cos 4 pi will be plus 1. So we get alternate plus minus because we want here plus minus plus minus. So therefore, we have to put in place of x as pi. Now if you keep x here pi, this will become pi minus pi 0. 0 square into a number 0. So you get like this, pi square by 2. If we kept here pi, cos pi will be minus 1. So this will become minus 1 by 1 square. Cos 2 pi will be plus 1. So plus 1 by 2 square. Cos 3 pi is minus 1. So this minus 1 by 3 square. Plus cos 4 pi is 1 by 4 square plus 1. So what is the next proof we have to do? Very easy. We have to prove this one. See here we have to prove like this, 1 by 1 square plus 1 by 2 minus 1 by 1 equals to pi square by 12. It's so easy. Let me do one thing. You bring these terms on the this side, minus, if you bring this here on this other side, will plus 1 by 1 square, plus on the other it will be minus 1 by 2 square, minus on the other it will be 1 by plus 3 square minus 1 by 4 square plus so on equals. Now what is left here? Left with the pi square by 12. Pi square by 12. So we have done one question based on Fourier series of the interval 0 to 2 pi. Okay, 0 to 2 pi. Inshallah, in the next class, inshallah, let me continue one more question based on the same method. Based on the same method, inshallah, we are going to continue the next class. So I request you all, if you are understanding the subject, if you understand this procedure of solving the questions, I request you all to like, share, and subscribe my channel, inshallah. We are going to continue in the next class.